But there is other types, guys, of mutation. So you guys can go to MATLAB and can simply select. Example, if you guys want to choose the mutation type, you guys can go here, and you guys can go to Google and can say, okay, I want to choose the MATLAB, right? MATLAB mutation. You can put MATLAB plus, and then you guys can choose the mutation function, right? So here you guys can choose how you want to change the mutation. Right? Here you guys have different types of mutation. Here you have the mutation function. So example here, guys, I want to change my mutation in the form of the Gaussian mutation Gaussian. You guys know the Gaussian distribution, right? Gaussian distribution. So
It's a normal distribution.
Sorry?
It's the normal distribution.
Yeah, the normal distribution, the same as normal distribution. So you can choose your mutation according to the Gaussian distribution, or you can use uniform. Uniform means constant. So you can choose the mutation in multiple ways, right? So MATLAB has different ways of selecting. So if you guys want to learn about how the Gaussian mutation, you guys can put help in MATLAB and then copy this mutation Gaussian, and it will tell you what is the principle for doing that. Okay. And also, guys, for the you guys can do the same thing for the crossover. How you want to do the crossover. And what about, guys, you want to do, example, crossover without mutation. Crossover without mutation, you simply remove the mutation. Okay. You can say I don't want a mutation. You guys can select that.
Would you want that in like a real life scenario?
In real life, no, you don't want to do this. Probably you don't want to do this unless the function is completely smooth. If it's very smooth, probably you don't want to do mutation.
Smooth like linear, or
kind of, it could be linear or could be you
just
have
like
a small variation, yeah, continuous functions, yeah. But in engineering practice, you want to add mutation. But typically, guys, let me guys show you something. Let's say we don't know, and we want to use a mutation of 90%. What happens if we use a mutation of 90% or 95%? That's a bad idea, because we are telling the model, hey, 95% has to mutate, only 5% has to be kept. That's bad because the solution keeps jumping and you are not going anywhere. Let's try it. Okay. So let's come here, guys, and then let's choose a mutation of. So here you guys can change, it can be uniform or Gaussian. Let me change here a mutation of 95%. And guys, my crossover is only, let's say, 0.02. Okay, so I'm not doing much crossover. Everything is mutation. This is a bad idea. So even though, guys, I have a large generation, a population, you guys will see, okay, let's click here. So you guys see the solution keeps jumping and jumping. Too much jumping is not good, right? Here, even though here you are not keeping much of the solution.
So the more mutation, the more scatter points.
Yeah, because it's jumping everywhere.
do the crossover fraction and the mutation, like, do those have to
More
sum to
or
100?
less be 100%. Yeah. Okay. So it found a solution, but it jumped everywhere. So actually, probably this solution, even though it looks close to 0, 0, probably it's not too close to 0 because there was no much improvement here. The solution was just jumping. And by jumping, it found close to 0.0. But if you guys make a zoom here, I can assure you it's not 0, 0. It is kind of, has some error there. Because the solution was just jumping and jumping. It was not improving around here. When you guys use crossover, guys, means a solution. If you find a solution that's good, the solution will improve around it. But if you use too much mutation, the solution will not improve around it. It will just jump. Okay, guys. So I don't know what's happening here.
Yeah, it's not exactly at 0, 0.
Sorry.
It's not exactly at 0, 0, the solution.
Yeah. So so guys, the mutation is not a good idea when the solution is kind of small. Is it working for you now? Okay, great. Yeah.
3, 4, 4.